On page 3, we are going to practice drawing angles in standard position, and we're going to start practicing with angles in degrees. If you notice, I have switched over to a 360-degree protractor. There's a couple of reasons for that. The first reason is that you can have an angle larger than 180 degrees, so you'll start seeing more of those types of angles. And the other reason I've switched over is because I want you to start thinking about, okay, if I am given this angle, how much of a single revolution does it comprise? Or how many revolutions does it comprise? Okay, so we got to start thinking in terms of a circle. All right, so let's take a look at our first angle. We're going to draw an angle of 60 degrees in standard position. Let's first talk a little bit about the protractor that we have. Every protractor is different. You really kind of have to study and figure out, where's your initial ray gonna go, where does the vertex go, and what set of numbers do you use, because it's always going to have two sets of numbers, an outer set and an inner set. Okay, so remember, on any protractor that you use, you are going to want you're going to want to go from, you're thinking more in terms of positive angles, so you're wanting to go in a counterclockwise direction. If you travel in a counterclockwise direction, you're going to want to go from 0 degrees on the right to 180 degrees on the left. Okay, so one more time, any protractor you use, you always want to think, if you're trying to figure it out and how to set up your angle, you want to think in terms of a positive angle, which is counterclockwise. When you travel that way, you want to travel from 0 degrees on the right over to 180 degrees on the left. Okay, so if you look at this particular protractor here, okay, let me get the highlighter here. If you look at the outer set of numbers, if you start on the right side, you see 0 degrees. Actually, I don't think that blue's showing up. Let's use green. If you start with 0 and you on the right and you move over in the counterclockwise direction, after half a circle, you'll reach the 180 degrees. So you're going to want to use the outer set of numbers with this particular protractor. Okay. Again, one more time, can't emphasize enough. You always want to travel from 0 degrees on the right in a counterclockwise direction over to 180 degrees on the left. Okay. All right. So we're going to totally ignore the numbers on the bottom. Okay. We will work, top and bottom with the numbers on the outside. Okay. All right, so let's talk about 60 degrees. We're going to have to draw each of these angles in standard position. And yes, there is no XY plane set up here. You just have a protractor, but you can kind of visualize one. So let's first talk origin or vertex. So when you look at this particular protractor, you want to kind of visualize the x-axis here. So you're looking at 0 degrees and 180 degrees, that mark. And you want to line the x-axis up with those lines that go through 0 degrees and 180 degrees. So like here's the mark. So I'm going to put it in black just so we can kind of emphasize it. I'm drawing a straight line through 0 degrees / 180 degrees. Okay, so when you see that, you can kind of think of this line as the x-axis, and you can do the same kind of thing if you were trying to visualize the y-axis. So y-axis, if you thought of it, it is going to go through 90 degrees, okay, up and down. So if you draw a line through 90 degrees, and that'll match down here with 270 degrees. Okay, let me see. Like I said, this thing it's sometimes kind of finicky to get these lines to work the way I want them to. All right, so probably about right there. Let's kind of make this a little longer. Okay, so I'm drawing this vertical line through 90 degrees and 270 degrees. Okay, so that's going to form your y-axis. Okay, so again, if you have a 360 degree protractor, there's not going to be an xy axis on top of it, but you can kind of visualize that it's there, and this is how you can do that. Okay, all right, so once you have that kind of visualized, then you can go ahead and put the vertex. The vertex will be at the origin, so I'll put that in red so you can see it. And then we're going to put down our initial side. The initial side has to coincide with the positive x-axis. So I'm going to start my line here at the origin and have this initial side coincide with the positive x-axis. So there we go. Okay, so there's my initial size and my initial side, and now I need to do my rotation. I'm going to rotate through positive 60 degrees. Okay, since the rotation is positive, or the angle is positive, we're going to do a counterclockwise rotation. So we're going to rotate upwards. Okay, you are going to start at 0 degrees. So look at the green numbers. You're going to start at 0 degrees and you're going to rotate until you get to 60 degrees. Okay, each one of these little tick marks is 1 degree, and remember there's 360 degrees in the entire circle. Okay, so we are going to rotate, and then our terminal side will end up through the 60 degree mark. Okay, so I'm going to go ahead and draw that in. Okay, so let's do that. All right, so here's my line. I'm going to make it line up exactly with 60 degrees. Whoops, hold on. Let's see. Come on, move. I am having trouble with this thing here. You want it to get it to line up exactly, because you don't want it to be like 62 degrees or 63 degrees. That looks pretty good. Okay, you want it to be exactly 60 degrees. Okay, so there you go. This is a 60 degree angle because you started at 0 degrees on the initial side and you rotated counterclockwise until you got to the 60 on the outer numbers. And remember what I've been telling you, usually you want to make a little arc closer to the vertex, and so start at the initial side and then draw an arc over to the terminal side, and you put a little arrow indicating the direction you went. Okay, so this red angle is a 60 degree angle in standard position. All right, let's try the next one. I am, for the remainder of the problems, B, C, and D, I am not going to draw the X and Y axes on here, but you can if you need to. But I'm just going to work with the protractor. Okay, if you notice with the protractor, see this little arc right here? That vertex is falling right here. Okay. All right, so let's move over to negative 90 degrees. So we finally have a negative angle to draw. Okay, so let's put our vertex down. Okay, we need to draw in the initial side, which is still going to coincide with the positive x-axis. Okay, so let's draw that in. Remember, start at your vertex. One of the points on the line is your vertex, and then you're going to have the line or the ray go through the 0 degree / 180 degree mark. Okay, all right, so there we go. There's the initial side. Okay, so since we are dealing with a negative angle, the rotation is now going to be in the clockwise direction. So we are going to rotate in the downward direction. Okay, so again, what we've talked about is, and I'm going to re-highlight these, that for this particular protractor, the outer numbers are the way to go. So I'm highlighting them in green, and you can basically ignore the bottom set of numbers. So if you are traveling in the clockwise direction and you look at these numbers, you see numbers like 350, 340, 330, 320, and so on. You don't see 90. Okay, you don't see 90 until you rotate all the way back up here. See where my cursor is? So we know what a 90 degree angle looks like. 90 degree angle is literally like an L. Okay, so what's happening here is you're going to rotate in the clockwise direction, but you're only going to go 90 degrees. Okay, so what happens here, you notice you start off, it doesn't go 0, 10, 20, 30 like it does in the other direction. So what you're going to have to do is figure out, if you go in this clockwise direction, how far do you have to go until you reach 90 degrees? Okay, so this is what we're going to do. Okay, because we're, it is not correct to start here and then go all the way around until you end up at 90 degrees. That's not correct, okay? So this is what you're going to do for these negative angles, okay? We know that there are 360 degrees in one circle, and we're going to subtract out 90 degrees, okay? And if we do that subtraction, that is going to tell us 270, okay? So we are going to start here with the initial side. We are going to rotate in a clockwise direction, and we're going to stop when we get to the 270 degree mark, which is right here, okay? That's going to form a 90 degree angle in the negative direction, okay? So let's go ahead and draw that in, okay? So start at your vertex, draw a line, okay, and draw it through 270 degrees, okay? So there we go. All right, so this is your angle, okay? I'm going to put that little square near the vertex to indicate that this is a 90 degree angle, okay? 90 degree angles have that L shape, okay? So this is a 90 degree, it's negative 90 degrees, okay, because we went in the clockwise direction, okay? Let me mention something here. Remember we talked about that term coterminal angles, okay? I don't know if you've noticed this yet or not, but in drawing any angle on a 360 degree protractor, you almost end up with two different angles, okay? So when we drew in this red angle, that was negative 90 degrees. But what if we looked at the angle? There was another angle that had been formed if we had traveled in the positive direction. So if you had taken the same initial side and you traveled in a counterclockwise direction to this terminal side, okay, that would have formed a different angle. You can see it's a much bigger angle. If you take the black angle, its measure, and you add it to the 90 degrees, it forms like a whole 360 degree circle, okay? This angle in black, okay, it is a positive angle because the rotation is counterclockwise. So if you wanted to figure out how big it was, just travel along your protractor. So you're going to start here at 0 degrees. You're going to wind around until you get to right here. This black angle is a positive 270 degree angle, okay? If you notice the black angle, because the black angle would also have the same initial side, the black angle and the red angle have the same initial side and they have the same terminal side, okay? Obviously the amount of rotation is different, the direction is different, but they are coterminal angles because they start and end in the same place, yet they are different angles, okay? So that was just something to mention. You know, I wanted to actually show you an example of coterminal angles. So that is definitely one example, okay? But here you were supposed to only draw the red angle, the negative 90 degrees, okay? All right, let's take a look at the two angles below. All right, so now we're going to try to draw 225 degrees in part C, okay? It is a positive angle, so we're going to rotate counterclockwise. Let's go ahead and put the vertex down, okay, and the initial side. Okay, so draw that initial side corresponding or coinciding, I should say, with the positive x-axis. So draw it through 0 degrees / 180 degrees, okay? Again, we are rotating counterclockwise, so in this direction, okay? We are familiar now with this protractor. We need to be using the outer band of numbers, okay? So what we need to do now is we need to start at 0 degrees, rotate to the left until we find 225 degrees, okay? And then we can place our terminal side, okay? All right, so let's do it. All right, so start traveling at 0 degrees, and hang on, let me erase this so we don't get confused. So start traveling at 0 degrees, go counterclockwise until you find 225, okay? So here's 220, Here's 230. You want to go right smack dab in between, okay? Every tick mark is 1 unit, and you can notice it's all the green numbers are going by tens, and so there is a halfway mark in between, so that's going to be 225, okay? So let's make our terminal side go right through this 225 mark right there, okay? So what you should do to finish this off, okay, you need to draw your little arc, okay? Start with the initial side and draw over in the clockwise direction, because that's the direction we traveled. Draw over to the terminal side, okay? You need to indicate the direction, okay, and with this little arc. You need to do that because remember, you could have been talking about this negative angle that it's coterminal with, okay? So be very specific when you draw your angles. Make sure you notate it properly, showing, hey, I went from the initial side to the terminal side by rotating this way, okay? All right, so this is your 225-degree angle. Here's the initial side. Here's the terminal side. It is your first angle that you're seeing that it is larger than 180 degrees. Okay. All right, let's try one more. Okay. Part D, we're going to try to draw a 405-degree angle. Okay, and you might be wondering, well, how am I going to do this? Because the protractor only goes to 360 degrees. Okay, you can do this. Okay, you can make angles as big as you want. You can have a 1,000-degree angle. You can have a 1,000,000-degree angle. Okay, angles don't stop at 360 degrees. Okay, so let's talk about how we would do this. Okay, let me go ahead and set it up. Let's put the vertex in. And let's draw the initial side, and then we'll go from there. Okay, so here's my initial side going through 0 degrees / 180 degrees. Okay, so it is going to be a positive angle, so the rotation is going to be counterclockwise. Okay, the problem is, or you may think it is, when you start with your initial side and you rotate, okay, and you come to one revolution, one full circle, you reach, when you get back to the initial side, you've gone one full circle or 360 degrees, okay? What's going to happen is you are going to keep going, okay? So you're going to keep rotating until you get to 405 degrees. That's how this is going to work, okay? So we're going to do a little calculation first, okay? We're going to do one full circle. That's going to bring us to 360 degrees, which is close to 405, but we need to figure out how much further past 360 to go. So we're going to take the 405 degrees and we're going to subtract out 360. Okay, and that's going to tell us, hey, once we reach the 360 mark, how much further do I need to go? All right, so if we do this subtraction here, let's see, 5 minus 0 is 5, and then 40 minus 36 is 4. So, okay, once we reach the 360 degree mark, we're going to have to go 45 degrees more, and then that will get us to 405. All right, so here we go. So I'm gonna, you know how I've been showing you, you've got to put the little arc every time you do one of these angles. It's especially important if you've got an angle bigger than 360, because it shows you how many times you had to rotate to get there. Okay, so I'm gonna draw my little arc. Okay, one full revolution brings me to 360 degrees. Okay, but then I'm gonna have to go up some to get to the 45 degree mark. Okay, so again, we're looking at these outer numbers. Okay, so let me highlight them because it's easier to see them. All right, so once you get to, you've gone one time around, okay, you're back at the initial side, you've gone 360 degrees, you can go ahead and kind of reset it to 0. You've got to go 45 more degrees. So you're going to go from 0 and you're going to find 45. Okay, so here's 40 degrees, here's 50 degrees. You want to go halfway in between. Okay, so that's where we're going to draw our terminal side here. Okay, So I'm going to draw in my terminal side right here through the 45-degree mark. Okay, so now I'm going to kind of complete my little snail here. I went a little too far here, so let me erase this right here. Okay, you absolutely have to have this little snail drawn where you started at the initial side and you rotated around 360 degrees, and then you went 45 more degrees to go through the 45-degree mark. So you've got to show this snail because it shows that you had to rotate one entire circle and then some to come up with the 405-degree angle. Okay, so this is what a 405-degree angle looks like. Okay, so I want to make a note here at the bottom. Okay, 405 degrees and 45 degrees are coterminal angles. Okay, so we just drew 405 degrees. What does 45 degrees look like? Well, if you had started at the initial side and rotated counterclockwise just 45 degrees, okay, so look at this little black arc that I put in here. So if you started at the initial side and rotated counterclockwise only 45 degrees, that would be a 45-degree angle, okay? Instead, if you rotated an entire circle, one entire revolution to the 360-degree mark, and then went 45 more degrees in the counterclockwise direction, you would end up at 405 degrees. So you can tell from looking at both the red angle and then this little black angle here, both 405 degrees and 45 degrees have the same initial side and the same terminal side. Okay, the difference is that, you know, this time they even have the same direction, but they differ in the amount of rotation that was performed. Okay, so here is another example of coterminal angles. Okay, this should show you how very important it is to put the little arc in when you draw an angle, because this is how you're going to designate coterminal angles. Okay, if you didn't have the little red arc versus the black arc, how would you be able to tell the difference between 45 degrees and 405 degrees, because they have the same initial side and the same terminal side? Okay, so make sure when you draw your angles that, you know, you put in your initial side, you rotate, you put in your terminal side, and then you go back and you show the direction. You put a little arc in to show the direction and, you know, the entire rotation that was done to go from the initial side to the terminal side.